Hi, this is JB Baker with ScaleFlux, and I'm going to talk about the performance of the CSD 2000. In particular, we'll go through a low-level benchmark and then show how that translates into improvements for your applications such as transactional databases. So first up, FIO. This is a tool that's commonly used to assess SSD performance. And what we're looking at here is sustained 4K random performance. Ordinary NVMe SSD is going to start off with a very high performance at 100% random read, but then start to decline very rapidly once you mix writes into the workload. You're running into garbage collection, die contention, and incurring write amplification. A lot of things that'll just start to slow SSDs down once you mix writes in with the reads. The CSD 2000, however, because of its built-in compression-decompression engine, is able to minimize those background tasks and sustain very, very high performance all the way across the mix of reads and writes. Now, as we move into the applications, the first one we'll look at is MySQL. And here we use sysbench to mimic different types of transactions that you might run against your SQL database. We're indexing against the NVMe SSD. And with CSD 2000, what we see is that across the various types of transactions, we achieve anywhere from a 20 to a 40% improvement in performance. And while that's great, it's even better if you can turn off the double write buffer, which, because the CSD 2000 supports atomic writes, you can turn off the atomic write buffer in your MySQL and still maintain your database integrity. With that double write buffer off, any transaction that has a heavy write component shows a massive improvement in performance. Here, over 2x the performance of an ordinary drive. And on the latency side, we're going to see a similar improvement where with the CSD 2000 with double write buffer on, you see anywhere from a 15 to a 30% improvement in latency. And then with the double write buffer off, another step improvement in your latency for those transactions that have a heavy writing component. In Postgres, there is a setting called fill factor that people typically leave at the default setting of 100 because reducing it increases your storage cost. With the CSD 2000 compressing the data, we avoid that increase in storage costs and allow you to take advantage of a lower fill factor to improve your overall performance. Here, by reducing the fill factor to 75, we're able to improve performance by over 35%. And lastly, we'll take a look at Aerospike. Aerospike is a very latency sensitive application, and they are really worried about outliers on read transactions. And to pass their test, you can't have more than 5% of your read transactions take more than 1 millisecond over a 24-hour period at a given pressure level. Here we're showing a 360,000 transactions per second pressure level, and one NVMe SSD was unable to complete the test. The second NVMe SSD was able to complete the test, but failed to meet the passing criteria. The CSD 2000, however, hums right along, passes with flying colors with well less than 1% of transactions exceeding that 1 millisecond. The other thing you look at with Aerospike is how high of a pressure level can you pass while still meeting the latency threshold requirements? Well, with competing NVMe SSDs at 3.2 terabytes, they pass at 240 and 300K transactions. The CSD 2000 goes all the way up to 525,000 transactions per second. Looking at some other capacity points, lower over provisioning here, a 3.84 terabyte drive. When we set the CSD 2000 to 3.84 terabytes, we over 2x the performance of the competition and a very small reduction in performance overall versus the 3.2. The other thing with the CSD 2000 is we're able to present the file system with greater usable capacity than we physically have capacity on the drive because we're compressing the data and it takes up less space. We give that space back. So here what we did was take our 4 terabyte drive, same one we used for the 3.2 and 3.84 measures, set it to 6.4 terabytes of user space, and then ran it against ACT, and we still showed 375,000 transactions per second while meeting the latency thresholds. So delivering on that cost improvement as well as the higher performance. So in summary, the CSD 2000 provides consistent performance across workloads which translates into improvements in application performance, particularly transactions per second, and your latency. For more information, visit us at scaleflux.com or shoot us an email at info@scaleflux.com. We'll be happy to answer your questions. Thanks for watching.